All right, let's take a closer look at question 2 of the mathematics paper 2 of November 2022, grade 12. All right, cool. So question 2 reads as follows. It says a company conducted research among all its employees on what percentage of their monthly salary was spent on fuel in a particular month. The data represented in the ogive cumulative frequency graph below. Okay, it is represented in the table below. You can also see the ogive, the cumulative frequency on the y-axis, and the percentage of salaries spent on fuel on the x-axis. Okay, cool. So now the first question, 2.1, says how many people are employed at this company? All right, now if you know what cumulative frequency talks about, okay, look, it's an aiding or a running total. Okay, it's like what happens over the time. So just keep adding whatever you're finding as the new value. For example, if you look on the y-axis, it will tell you that after we have done the survey, in total, we ended up with the highest value of the cumulative frequency here being 60. Okay, that means all the people that were surveyed, we kept on adding people between people who spent 5 and 10%. We had a certain number, and then we looked at people that have spent between 10 and 15%. We got a number, and then we looked at people that have spent between 15 and 20% of their salary on fuel. We kept on adding and then kept on adding and then kept on adding. After we've added all the people, we ended up with the highest cumulative value of 60. So I think we can clearly say, it's safe to say the number of people that are employed in this company is 60 in total. Okay, so 60 people are employed here. Right, now we're going to go to the next one. What's the next one asking? They're saying to you, we need to write down the modal class of the data. So modal, okay, modal, I think we all know that from ungrouped data, mode implies the most common, okay, the most common or the most occurring score, right? This is what the mode would be. But now we're talking classes. That means the modal class will be the class with the most entries, okay? Will imply the class with most entries. All right, now we don't have a table. Usually it's easy to read this from the table if you have a table. So what I'm going to do here is check the class with the biggest jump. Let's put it this way. If I was writing this information in the table, okay, if I was writing this information in the table, what would I get, grade 12? What would I get if I was putting this information in the table? Of course, I will have the percentages of salaries, okay, percentage of salary spent on fuel. Okay, I will have that here. All right, and then I will have the frequency on this column here, okay, which we can obviously convert to cumulative frequency. Now you will see there on the x-axis, you count the moves from 5 to 10. For this very first class here, okay, how many people can we say we have when you're looking at the values between 5 and 10%, okay? How many people do we have? So you will see from this dot to that dot, okay, the value at 10. The number of people that I'm reading here, I think on the x-axis, at 10, the corresponding y value will be somewhere here around 7, okay? It's going to be around, let's see, 2, 4, 6, around 5. It will be having a value of 5. So that means we have 5 people. The jump from a y value of 0 to the next y value at that second dot there is giving us a value of 5. So I can tell you now, there are 5 people with a percentage between 5 and 10% that spend between 5 and 10% of their salary on fuel. So there's about 5 of them in total. Now for the next class, the class between 10 and 15. This is the second class. Class number 2, between 10 and 15, right? So the class that you would have between 10 and 15, you're looking at the dot from this dot here to that dot here. You're just counting what is the vertical move you're making going up, okay? How much more people did I add to get the new cumulative frequency value? And I think you'll agree with me that you can see that the value on the y-axis at which the second dot is going to be found is exactly at 12, okay? Because on the y-axis, they're going up by multiples of 2. So it's 12, 14, 16, 18, 20. So that value that I'm looking at there is actually 12. Now, from 5 people to 12 people, how many people are we adding? I think you'll agree with me, from 5 people to 12 people, we are literally adding nothing less than 7 people. Okay, we're adding 7 people. So this idea will help us to understand how you can work out the class that is going to have the biggest number of people. Because the move you've made here going up is literally going to be 7 people. You added 7 people. Now to move from this dot to the next dot, how many people am I adding as I'm going up? How many more people am I adding to get to the next value, right? And this is how you can continue working out your frequencies for each one of the classes. So if you look at the graph, closely, you'll see that the class that has got the biggest jump happens to be the class from 20 to 25. Because this class here that moves from 20 to 25 is the one that looks like has the biggest jump of all the graphs. So it means we added more people in that group to get to the next dot. It literally grows bigger than all the other values. So what I'm interested in is figuring out what is the original Y value that we had at the first dot and how much jump are we making as we're going up. So I'm trying to figure out the spacing between the first dot and the second dot. So the first dot looks to be exactly at 24, okay? And then because it's 22 and 24, that's where it's currently located. And then the second dot is somewhere here between these two. So if I move to the left with my dotted lines for you to see what I'm talking about there, I think it's safe to say we are reading this at 40, somewhere at 45. Remember, it doesn't have to be exactly the same as the one that they have on whatever you're looking at. So that class there, it's literally moving, it's got the biggest jump than all the other graphs, the other dots from one dot to the next. Okay, that's the class that happens to be having the most entries. They're not really asking you how many people were added there. If they were asking that, you could literally read off the difference between 45 and 24. Will tell you on top of 24 people, how many did you add to get to the value of 45. Okay, very important. But now they were just asking which class is that. It happens to be the class between 20 and 25. So that's going to be my answer in this case. Okay, so the modal class will be the class with values between 20 and 25 because it happens to be the one with the biggest jump going up. Okay, cool. So number 2.3, question 2.3, let's go to question 2.3. Says, how many employees spend more than 22.5% of their monthly salary? How many people spend more than 22.5%? So what we're going to do is we're going to go back to our cumulative frequency curve. We're going to look for the percentages because the percentages are on the x-axis. We will try and find who has spent 22.5%. Okay, remember the ogive looks something like that. So then we're going to say, okay, fine. After I locate 22.5, I'm just going to go to the graph and ask it, okay, please tell me where is this on our cumulative frequency column, because that cumulative frequency column is the one that we have on the y-axis. So whatever the number that I have, it means that from that number going down, those people spent less than 22.5%. But then from that number going up, those people spent more than 22.5% of their salary on fuel. Okay? And which one is the question they're asking? They're saying how many employees spend more. So I'm interested in knowing who is at that number there going up. Okay? That's the people that I want. I want to know how many do we have here. Remember, the highest possible value is 60. We only have up to 60 employees. So I'm interested in that value. How much or how many people would lie in that particular range? Okay, so let's go back and find the 22.5 first of all. I'm going to clean this so that it's easier for us to be able to see what we're interested in. Okay, so let's look for 22.5% on the x-axis. We've got 20 and then we've got 25. I think 22.5 is exactly halfway. That is where you're going to get 22.5%, right? So now I'm going to say, okay, if this is 22.5%, what is the corresponding cumulative frequency value? Okay, by the time we got here, how many people did we have? So I'm going to go this way and read what number do we have here. And it happens to be between 30 and 40. I think 32, 34, it's safe to say it's around 34 or 35. Okay, around 34 and 35. So I'll have mine here as 34. Okay, let's say there's 34 people here. So if I have 34 people, it means by the time I got to 22.5%, the people that are below are going to be 34 in total. So from 34 to 0, I have 34 people in total. Now, since we're going all the way up to 60, I'm interested in finding how many people lie in that particular range. And I'm sure you guys will agree with me, it's just the difference between 60 and 34. We'll have to have 60 minus 34, and that gives us a total of 26 employees. Okay. Now, question 2.4. Question 2.4 says an employee spent 2,400 of his salary on fuel in that particular month. Determine the monthly salary of this employee if he spends 7% of his salary on fuel. Okay, cool. So somebody spent 2,400 and it turns out that 2,400 is 7% of his salary. Okay, now we just have to find how much does this person earn. So this is going to be a very simple question. You ask yourself a simple question. 7% of how much is 2,400? Or 2,400 is 7% of how much? You can also look at it in that way, okay? Because 2,400 is supposed to be 7% of whatever this person happens to be earning. Now, how do you write 7%? It's 7 over 100. How do you write off? It's times an unknown amount. It should give us the value 2,400. Okay, now quickly, simple basic math. I think our x value is going to be 2,400 multiplied by 100 divided by 7. And I think from this calculation, we should get the answer 34,285 rand and 71 cents. This guy is earning that much, 34,000. Good money, very good money. Okay, cool. Now we're going to go to the follow-up question, which is question 2.5. Question 2.5 says the monthly salaries of these employees remain constant and the number of liters of fuel used in each month also remains constant. If the fuel price increases from 21.43 cents per liter to 22.79 cents per liter at the beginning of the next month, how will the above graph change? Okay, now let's try and think about it. We want to see how the graph will change, the ogive. The original ogive that we have is very simple. Okay, it starts at 5 and goes something like that. We are interested in the percentages. You have to look closely. The number of people will not change. We still have 60 people in our survey. The company still employs 60 people. But now the percentages of the amount of money they're using, okay, is what we have to pay attention to. We know for a fact that they spend between 5%. If I go back to the graph and we look at it, we'll see that it's up to 35%. So the smallest value on the graph is 5%, and the biggest value on the graph is 35% of their salary. So someone is spending 35% of their salary to try and cover costs of fuel. That's a lot. Okay, so it goes all the way up to 35%, okay, from 5% of your salary up to 35%. Now, they're saying to us here, the monthly salaries of these employees remain constant. So the money that they're earning stays the same. The number of liters they use each month also remains constant, but the fuel price is increasing. So that means if you had 100 rands, okay, and you're spending 10% of 100 rands, which is 10 rands, on fuel, okay, that's 10%, 10 rands on fuel. But now the price increases. Now you have to spend 12 rands from the same amount. You have to spend from the same amount. Your salary did not change. It still stays the same. Now you have to spend more money because the fuel price has increased. You're now spending 12 rands. I'm sure you guys can see that you're now spending more percent than you did in the beginning. You have to spend a higher percentage of your salary to cover the cost of fuel because you're still traveling the same distance, you're still using the same fuel, and your salary is still the same. So the only thing changing is the cost of fuel. That means you have to dig deeper now. That implies that the graph will have to move to the right. So it's going to move to the right because if you are spending 5% of your salary to buy fuel, you need to spend more. That means you're now going to spend a higher percentage. So the new graph is likely to look something like that. So our answer to this question that is asking here, how will the above graph change? We'll just tell these people, oh, well, this graph is going to change in the sense that it will shift to the right. Okay, it's going to have to shift to the right because you have to spend a higher percentage now than you did in the beginning. So we'll just say it will shift to the right. Okay, that's actually how you can answer this awesome question.